Hey, what's going on, guys? In this video we are going to see how to prove a proposition if it's with a max and minimum. Okay, here we have a max statement right here. So we had to, whenever we have max or minimum cases, we had to use two cases to prove this one. So here this is if then. This is our claim. The one that comes after then is our claim. This is our claim. This is what we want to prove. So we have to use this one to prove this one. Now first we let x comma y to be belongs to real number, and also we assume the first one, that is x is greater than 0 and y is greater than 0. Now we have to prove this one in two cases. In the first case, what we do is case one we say x is greater than or equal to y, and in this one we know that x is maximum. We are only considering maximum right here, so let's take the maximum. Maximum is maximum of x comma y, because x is greater than y, that's why x is maximum. Maximum is x, and also if you rearrange this equation you will get x minus y is greater than 0. So if x minus y is greater than 0, if you take the absolute value of x minus y, that's going to be equal to x minus y. Okay, we are going to use this one later, and we know that x minus y is greater than 0, and we have this one, and also we know that y is greater than 0. Y is greater than 0. If y is greater than 0, then we know that the opposite of this one is negative. Negative y is less than 0. Okay, because sometimes y can be a negative number. Since we have this one provided, y is greater than 0, we know this is definitely a positive number. Therefore negative of y should be less than 0. So if it's less than 0, if we add x to both sides, x minus y, and in this side we will have x. So x minus y is less than x, and we know that x minus y is equivalent to absolute value of x minus y, absolute value of x minus y, and x is our maximum of x comma y, because that's the one biggest. So maximum of x comma y. So we proved this one by first case, because that's what we want to prove. We want to prove absolute value of x minus y is less than maximum of x comma y. So we proved this one by first case. Now in the second case it's going to be opposite. Like in the case 2, what we will have is we will have x is less than y, opposite of this one, the negation of this one. Okay, now let's go ahead and prove this one. Let's get rid of this because we need some space. Okay, let's go ahead and continue right here. In the case 2, we have x is less than y, or you can say y is greater than x. So if y is greater than x, we know that y is greater than x, then x minus y is less than 0. Or you can, if we write in this way, it's better to see it clearly. Okay, x is less than y, so I just move this y to this side. X minus y is less than 0. So this means this is a negative number. So if you take the absolute value of this one, x minus y, absolute value must be a positive number. So it's going to be reverse order, because in order to make this one positive, you have to take the negative command. If you take the negative command, it's going to flip around. It's going to be y minus x. So absolute value of this one is equivalent to y minus x. Okay, and we know that x is greater than 0. X is greater than 0, and if we add y to both sides, in this case, yeah, if we add y to both sides, is it gonna help? Let's see. So it first, if x is greater than 0, we know that negative x is less than 0, because if we add y to both sides, we cannot bring this pattern. We have to have a negative number. So first we take what is negative is, if x is greater than 0, the negative of that one should be less than 0. So now we can go ahead and add y to both sides. If we add y to both sides, it's going to be y minus x is less than y. Okay, I just added y to both sides, and y minus x absolute value is equivalent to x minus y absolute value. And we know that y is our max in this case. Max of x comma y is y because y is greater than x. So since y is max of x comma y, instead of y we can replace max of x comma y. Therefore we prove this one by second case too, because this is what the claim is. X minus y absolute value is less than max of x comma y. We prove this one by both cases, therefore this statement is proved. And that's how we do that. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.